Hmm. there's something familiar about being back on Zoom, and then everybody filing in at like 2 minutes till and 1 minute till. Uh, the world that was in lockdown was crazy. Everybody had their timing to a T. Wait for a few more people to show up, and then we'll go ahead and get started.
Good evening.
Hi, Joe. How are you?
Okay.
All right, we'll go ahead and get started up a little after 7. Hopefully everybody's doing great. I'm Todd Beckerman, current president of BSAS. Thank you for all tuning in today, and thanks for the quick pivot to online as opposed to meeting at our wonderful observatory. Those of you that have been to the observatory know how much of a pain that hill can be during just wet weather, let alone ice and snow. So thank you all for showing up on Zoom. Today, what we're going to do is we're going to start off with our presenter today, Dr. Jason Dworkin. I'm going to shut down my screen real quick and give Jason access to the screen. Dr. Dworkin, I met him at Green Bank Star Party a couple times, where he's talked about his work with OSIRIS-REx mission and them wanting to land on a pretty cool rock named Bennu. And so Dr. Dworkin's going to be here to tell us today a little bit about some of the findings that they've found. So go ahead, Jason, take it from here. Thank you.
Thanks for having me. Yeah, so this is asteroid Bennu. It's a half-kilometer across object you can see rotating. And this is a story about how we got there, the troubles along the way, and how we recovered, and what we found so far. And this is a a large group of people have been working. I've been working on this for 21 years now. So, let me start with a mention of our first PI, who sadly passed away right after selection. This is a plaque on the spacecraft that is currently orbiting the sun, that reminds us of his inspiration and some of the reasons that we're here. Then I'll follow this with a quick video to orient you and help you see where we're headed.
I think one of the age-old human questions, perhaps going back to the beginning, is how we align, and that maps directly into why we're here.
OSIRIS-REx is 3 missions in one to make that kind of exploration cost effectively for not much more than the price of a rocket.
There's been nothing like OSIRIS-REx in NASA's repertoire. I like to call it the Daredevil spacecraft.
We're going back to the dawn of the solar system. We're looking for clues as to why Earth is a habitable world.
And of course, the biggest question, the one that drives my scientific investigations, is the origin. What is life? How did it originate? And why was the Earth the place that it occurred?
10 seconds. 9, 8, 7, 6, 5, 4, 3, 2.
And this is actually a full-length film that's on NASA Plus. You can watch if you want about the developments. And so we'll start with this beautiful image from the James Webb Space Telescope, since you're an astronomy club. And this is the Orion Nebula. And in it, you can see that there are stars and formings, as well as planetary systems. So here's one. You can see the disk forming around the star, and the cocoon as it's interacting with the molecular cloud that it's forming inside of, and this is a scale bar of the size of the orbit of Neptune. So this is immense. And this is related to, as our PI Dr. Loretta said, the origin of life on Earth and possibly elsewhere. Because we know that life on Earth is all interrelated. This is an RNA tree connecting organisms that you know and love, from yourself through rice, to all kinds of to every organism on the planet. They all share the same sorts of biochemistry, the same sorts of genetic machinery. So they're all related from this last common ancestor shown down here in the middle. And so to understand this, we have to look and try to understand the ancient Earth. This is a cartoon from the webcomic XKCD that asks, the Earth is 4.5 billion years old. We know it had liquid water from the formation of the zircons that are in the caption. But all the crust older than 3.5 billion years ago is lost from subduction and from alteration from geology and biology. But the Earth is silent on this history. All we have are these zircons that tell us that there was water early on in the large oceans, as well as scars on the face of the moon that tells us that there was a bombardment history of the Earth-Moon system early on in geologic time. And so we can look at these processes, the formation of star systems in these dense molecular clouds, and the cycle of matter from diffuse to dense to stellar death, as well as the ancient Earth or other objects. And the problem is that the early Earth is only known about through simulations in the laboratory and on models based on what we see in geology. And as you well know, when you look at stars, you can only observe them remotely. When it comes to getting pieces of rock in your laboratory, That's where you can talk about sample return missions, and understanding these complicated chemistries more thoroughly. So, for example, you can do infrared observations of you can tell the difference between a gas and an ice. You can see here, and in fact, even the same elements rearranged from one set of molecules to another is quite distinct. When it comes to complicated species, you can't really tell the difference between an apple and an orange. They look fundamentally the same. And so only by getting an apple and orange in your laboratory can you tell the difference. And so you can see that apples have more fructose than oranges do, for example. And that's the power of bringing materials in your laboratory for close study. And so we study rocks because rocks have this history that is preserved, the history of the solar system, and the history of Earth. These are largely preserved in meteorites, which we have a huge wealth of them to study. And they are broken up into different categories. The ones that are most interesting to us are these carbonaceous asteroids, carbonaceous meteorites on the bottom, which are carbon rich, often water rich. Some of them not heated very much. And so I'll be referring to the Orgay meteorite here, which is this kind of ugly black piece of rock that's falling apart. It's very fragile. That's a very primitive type of meteorite. That's the CI class. And they make a very small percentage of the types of meteorites we see on Earth, partly because they aren't so much in the inner solar system, but also because they're so fragile, both by total numbers and of course by total mass. And as I said, the more primitive types of asteroids are the C class and B class, and these are this is an arrangement of the abundances of these types of rocks in the asteroid belt, moving from Mars to Jupiter. And here's the location of Ceres with the Dawn probe, and the Psyche probe going to Psyche about here, and the Lucy mission going to explore the Trojan asteroids in the same orbit as Jupiter. And so there's a variety of different kinds of asteroids with an abundance of the more altered, the esthetite, the silica-rich, carbon-poor ones closer to the Earth in the inner solar system, with the ones of greatest interest further out. And so meteorites are great, but they suffer from a problem. The one is that depending on who is hunting for them, they can either be interested in fame and profit, which case they need to keep their locations secret, and aren't always then they're concerned more about getting samples necessarily than are preserving the integrity of the meteorites. The second one is the case of the Alma-Ata Sita meteorite, which is the first meteorite that was observed as an asteroid and then fell in Sudan. There have so far been 3 of these asteroids that have been detected first and then fallen. This was the first one. So that's one of the very few cases where you have a meteorite where you can trace it to a specific object. To samples collected in Antarctica, which is a great place to get meteorites because Antarctica is white and meteorites tend to be black. And there's relatively little terrestrial rock that you can see, a fair strewn field of it here in this image. But these are again mixed up. We don't know where they're from, and they have been sitting in the ice, even though the ice is pretty clean. They've been sitting there for 10,000 years or so. And best of all is you have a sample return mission where you can get a specific sample from a specific location on a specific asteroid that's been in a chain of custody to make sure that it is been collected and taken care of very well. And I have a typo here, so sorry about that. And so there's been a variety of sample return missions since Apollo 11, the first one, where astronauts return samples from the moon, as well as robotic missions from the Soviet Union, and then more recently from People's Republic of China. And in the future, the Artemis missions will be bringing back more samples of different locations of the moon. But after 1976, there was a long pause until 2004, where the NASA Genesis mission returned atoms of solar wind for study. And then the Stardust mission returned samples from the tail of a comet. The Japanese had two asteroid missions in a row, Hayabusa and Hayabusa 2, which were the first two asteroid sample return missions. And OSIRIS-REx was developed around the same time as Hayabusa 2, but the timing was such that OSIRIS-REx returned a little bit later. And then in development is the MMX mission by JAXA, which is going to get samples from Mars's moon Phobos. And then in the future, NASA and ESA are planning to bring back samples from the surface of Mars. So OSIRIS-REx is the mission I'm talking about. It is an acronym which stands for the mission objectives: origins, spectral interpretation, resource identification, security, red glyph explorer. My main focus is on origins, the origin of life, the origin of the solar system, and to that we need to analyze this sample of pristine carbonaceous asteroid red glyph. There are a lot of asteroids. This is a view of the solar system. Here's Jupiter, and you can see the Trojan asteroids following it, perhaps. And then the main belt is in red, is in green here. The orbit of Earth is in blue. Mars is in this faint yellow color, and the yellow and red dots cross either the orbit of Earth or Mars. And in white here is the orbit of Bennu, our target. And this is a great visualization from YouTuber Scott Manley from many, many years ago. When we designed the mission, at the time there were only 500,000 asteroids known. There are now 1.3 million asteroids, but at the time only 500,000. We needed to get to an asteroid that was near enough to Earth that we could get there and back within the lifespan of the team. So that meant none of these green ones would work. It had to be one of these red asteroids. We needed one that was within the plane of Earth's orbit, so it didn't require too large of a rocket, too much delta V. So meaning a rocket that existed and we could afford. Of those, there are only 192. We needed an asteroid that was large enough that it didn't have too small of a diameter, where asteroids less than 200 meters in diameter tend to spin up to something called the Yorp effect, where they can revolve at as fast as one revolution per minute, and one that makes a huge problem for the navigation team. And secondly, we're looking for the loose regolith, the rocks and dust on the surface of the asteroid. Those will be thrown off. That leaves with 5 asteroids, which had spectra that told us that they were carbon rich. There may be other ones, but most of these asteroids don't have spectra that you can look at that haven't been taken. And of those, Bennu was the best characterized by a suite of ground and space assets, so we could understand the shape and spectra of the asteroid, and thereby buy down our risk. So here is an Arecibo shape model of asteroid Bennu, half-kilometer across. For comparison, this is where you aren't today because of the snow, but that's your usual meeting place around at the same scale. So you can see this is a quite, if it wasn't for the gravity and the vacuum, a walkable asteroid. And by the way, here is some of the value of buying down that risk. Here is the shape model of asteroid Bennu based on radar for asteroid 67P Churyumov-Gerasimenko that was visited by the Rosetta mission. They were only able to get light curves, which is based on the change in brightness and darkness as the object rotates. And so this was their best shape model before arriving. This was our best shape model before arriving based on radar. And you can see here is the shape of Bennu after arrival, which is a very good match for what we saw, as opposed to the shocking bilobe comet that ESA had to deal with. So we have a bespoke spacecraft that was designed specifically to go to this asteroid and collect the sample. It is like most other spacecraft you would have seen that has a communication dish, star trackers, a flight deck, an instrument deck that has an array of spectrometers and cameras, but also has a 3 meter long pogo stick that has the tag SAM head that is designed to blow a jet of nitrogen gas upon touching the surface for less than 10 seconds, and then disturbing the regolith with the jet of nitrogen gas and trapping it inside of this canister that looks like an old car air filter. And in fact, the first engineering name for it was MooCab, which is vacuum sealed backwards, because it uses the vacuum of space as the destination for the nitrogen gas that's passed through, invented by an engineer on his driveway with a solo cup and an air compressor. Once collected, and then of course refined and made and perfected for flight. Once collected, it's put inside of the sample return canister, and that's the bit that comes back to Earth. The rest of it stays in space. Now, it was not a straightforward path to get to this mission. I mentioned I've been working for over 21 years. We had a first proposal in 2004 that was not selected. We revised our plan in 2006. That's when we selected Bennu as our target. And we made it through a competition to second place, but we're not selected. We tried again with now OSIRIS-REx, which was at a larger price point that did more science, because we could demonstrate that we could not achieve our mission credibly under the Discovery 12 price cap. So we eventually were selected May 25th, 2011 to begin work. This is after submitting 2 trucks full of paper proposals that had to be driven down to Virginia to be submitted. But once you're selected, NASA doesn't just have a dump truck full of money that they drop into your offices. There's lots of oversight and lots of care to make sure you thought of everything, and that the system is well understood before you start cutting metal. So lots of reviews, and then lots of design and testing and construction, all of which led to launching on time and under budget, 150 milliseconds in the opening of the launch window. So I'm very pleased that we're able to do that, and then the excess budget was able to be rolled into the science campaign. There were problems along the way. One of the instruments, that's very hard to see, was the infrared spectrometer that had its prime and backup housing accidentally in the same location at the same time due to an error in shipping when the factory burned down, destroying both the prime and backup. But they're able to refurbish the flight, refurbish the engineering model for flight. Also excitingly, a week before launch, the SpaceX Amos 6 spacecraft or launch vehicle exploded about a mile from our spacecraft, which was fully fueled and ready to launch. That was an exciting, nerve-wracking day, but our safety protocols did work, although imperfectly. Also, you can't see here, right between them, there's a shared water pump that kept the both sets of launch pads cool, because this was the Florida summer, and that went down from the pressure wave, and so we had to have trucks brought in for cooling water to keep the spacecraft batteries from exploding from the summer heat. So again, exciting day. The mission is not just the hardware, it's the people. And so, as I mentioned, our PI is Professor Don Loretta. Our first PI, Mike Drake, passed away soon before selection. It's a large team. This is a small fraction of them. I'm the project scientist, and the project scientist is, at least in our principal investigator-led mission, is the voice of science to the engineers, to tell the engineers that what they're going to do is to destroy the science and that they should stop it. the voice of engineering to the science team, that is to tell the scientists that their requests are unreasonable and will blow the budget and break the spacecraft. And then confidants and loyal opposition to the principal investigator and project manager to tell them that they're driving the team insane and they need to let up. So I'm everybody's friend.
3,
Um,
2,
this is the launch, and I think they've got time to show it, but it was a nice launch at sunset. This is on an Atlas 5 for 11, so it has one solid rocket booster. That means it has asymmetric thrust, but it sort of slides sideways off the launch pad. There's the solid rocket being ejected, the first stage being ejected, fairing released, and then finally the bottom end of the spacecraft you can see going off into space. What's next? And this is the last time we'll see the bottom of the spacecraft. On the way out to Bennu, we got to exercise our instrumentation to see that they worked. And so here is the very expensive professional level camera system on board a spacecraft outside the Earth's orbit, taking the first image, and rather terrible image of Saturn and three of its moons, as well as the discovery of an existing asteroid. These cameras are designed to look at a very, very dark object close up. So this ain't Hubble. In fact, it's far worse than the telescopes you have in your club. But this was an exercise to make sure that that they worked and that our pipeline for data worked, but also to illustrate that just because it's in space and expensive doesn't mean it's good for everything. We had a mission plan, which allowed us to go through various phases on moving in closer and closer to the asteroid, where eventually our smallest maneuver was 0.1 millimeters per second around the smallest asteroid ever, or smallest object ever orbited in the smallest orbit. So getting us 2 Guinness Book World Records. But on the way, we had a number of other issues that I'll mention briefly just for your amusement. And so on the way, before arrival, there was a fire near the Canberra Deep Space Network telescope, which would send commands to the spacecraft to get us into orbit. We entered orbit or entered proximity to the asteroid a few weeks later, so this turned out not to be an issue, but it was our first of many nerve-wracking events while the spacecraft was in space. We entered in the proximity of Bennu and started doing surveys until the government shut down. And so we lost the majority of the team, including myself. Then just a few days later, there was a nationwide internet outage. And this was the day that the spacecraft was about, or day before the spacecraft was about to enter orbit for the very first time. But unfortunately, it was also Christmas vacation. So an engineer from Lockheed Martin in Denver happened to be in Los Angeles. And even though they couldn't send the commands over the secure line to the Deep Space Network in Los Angeles, the engineer could drive the commands on a thumb drive and to the Deep Space Network to be able to upload the commands and drive the spacecraft that way. We entered orbit. This was our first and highest orbit, and we're shocked to discover that the asteroid was spitting out rocks. These are a few centimeters across. They're extremely interesting scientifically. They were nerve-wracking until we realized that, well, this is a very small object. These rocks are moving extremely slowly, and they're very small, and space is very big. So the probability of actually hitting one is minuscule, and we never did. But what it did instead was give us a lot more information for the gravity calculations. So we had all these other objects to follow to understand the gravity and the interior structure of Bennu in much higher magnitude. Now, I wasn't worried at all because I was at home furloughed. I had no idea this was happening. Soon after that, I was allowed to go back to work. Hooray. And then we entered into different orbits or different viewing positions around Bennu. In this case, there was a weather event where Lockheed Martin shut down, and we had to use the backup Mission Operations Center at Goddard. That was a rare event for the snow is so bad that Denver shuts down. These are various different positions looking at the surface of Bennu from different angles for taking better spectroscopy, and now looking at our final 4 sampling sites in much greater detail. And to do this, you have to drive the spacecraft. The spacecraft is up to 20 light minutes away. So you send a command, you wait 20 minutes, the spacecraft gets the command, does the thing, and then tells you it did it. You don't know about that 20 minutes later. And so you can't just drive it by joysticking. You need to send commands well in advance. But you can barely orbit this object, and these other things are these station keeping locations aren't in orbit at all. And so there's a higher and higher error that comes in about where your spacecraft actually is. And so we had the science team taking measurements with the cameras on the surface of Bennu and feeding that information to the navigators. This was usually a 24-hour process to figure out exactly where the spacecraft was to send the next command. Because the Madrid Deep Space Network went down, this had to be done in 4 hours. And so this was an infamous day in the minds of the navigators and optical scientists. Then further understanding Bennu and getting into closer orbits to prepare our rehearsals and choosing our final 2 sampling sites when the laser altimeter low energy laser failed after more than its lifespan, but that was the focus mechanism for one of our cameras. So we had to refly this observation to get close images of our secondary sampling site, which cost us about a month of time. Then getting ready for our final rehearsals before we do our maneuver, and we had a pandemic and had to learn how to fly a spacecraft remotely and how to work together all across the country. During this, we learned a number of things about the asteroid. We learned that it has a 1 in 1,750 chance of hitting the Earth in the late 22nd century, between 2179 and 2300. It had been the most potentially hazardous object until this latest one was discovered that now has about a 2% chance of hitting the Earth in 2032. But that's a much smaller object, and so if it hits, it'll be less of a calamity. So when Bennu comes close to the Earth in 2135, it'll pass through a close location, which will set it up to either hit or miss the Earth. And so the data we have from observations of Bennu, from the samples from Bennu, as well as the successful DART mission, will allow scientists and engineers and managers and politicians and the public to make decisions in 2136 about whether or not and how to divert Bennu if necessary. Because if Bennu hits, it would be a substantial event, regional disaster. But again, that's in no earlier than 2179, so a lot of time. Here are the 3 asteroids that we have samples from. One is Itokawa, brought back by Hayabusa. It is a very dry, stony asteroid with an irregular shape and a regular spin. And as opposed to Ryugu, visited by Hayabusa 2, and about half the diameter is Bennu, visited by OSIRIS-REx. Those are rubble piles instead of bilobate asteroids, so they're roughly spherical, very loose piles of rubble that may come from the same dynamical family, the same origin, and the in the in the inner main belt of the asteroid belt. They have similar colors, similar albedos, but different levels of hydration and different amounts of minerals. And certainly we can see in the close-up information that there are some significant differences, even though they may have come from the same origin in the asteroid belt. So we designed the mission to land or collect a sample with a 10-second touch in a 15-meter diameter circle somewhere on the asteroid. We believe that the asteroid was going to be smooth based on the thermal inertia data. That is, how quickly or slowly the rock warms up and cools down as it moves from sun into shade at night, and vice versa. The data was accurate, our interpretation was wrong. Turns out that it's a very rocky surface without any area that has a 50-meter clean ellipse, but those rocks are not well thermally connected. And so we couldn't trust our spacecraft to be able to touch one of these large rocks and come out unscathed. So instead, we needed to use something called natural feature tracking, where instead of using LiDAR to land within the 60-meter ellipse, we had to use our navigation cameras to autonomously navigate based on certain boulders on the surface that had picked out and made a map of, and then descend within an 8-meter sampling ellipse. Even within that 8-meter ellipse, there were still areas that were dangerous, the red and yellow zones, where if the spacecraft had touched it on the end of this pogo stick, it could have tipped and come off at an angle and hit, say, this mountain that we nicknamed Mount Doom, and smash into that. So as it was, we were able to touch the center of the ellipse, only 73 centimeters from the center, which is, again, amazing navigation. And here's some of the excitement of that happening. This is November 2020, so still middle of the pandemic.
This is ORX systems on board. Copy all subsystems or go for tag.
The spacecraft had the spacecraft is autonomously descending 18.5 light minutes away from Earth. It touched the surface, and you can see it blew up this huge cloud of regolith. The tag arm touched the surface. Actually went half a meter below the surface, collected the sample. At five, if there was a problem, the spacecraft could have aborted at 5 meters. And we could have done it again. We had a backup site and enough gas to do 3 independent tag attempts. And then moved off away from the asteroid. So here is again the descent, and we are looking at 2 cameras. The sample camera looking down at the sampling head here in red. Orange is our sampling ellipse, and here's a navigation camera in green. You can see its footprint as it descends. This is descending at 10 centimeters per second, which is free fall. So it's not being propelled; it's just falling under the very low gravity at Bennu. Just literal micro G's. Here's the shadow of the tag arm. Touches the surface. This rock here just explodes. The tag arm goes below the surface. Gas fires. There's regolith flying everywhere. The spacecraft automatically backs away. You can see that the square is getting larger. You can see this ridge of regolith being blown into the sky as the spacecraft backs away into a safe location. And then you can see the ground through past the shadow of this arc of dust and rocks. And we did make a hole in the surface. So here is the initial location, and we made this divot where the tag head fired its gas, as well as 4 divots from the thrusters. This actually is a maneuver that will be done by the extended mission called Osiris Apex that is right now headed towards asteroid Apophis to rendezvous in 2029. And it'll do what they call an air tag, which is this maneuver without a sample, but just to see how the surface is altered by firing the thrusters. To our horror, after collection, we took an image of the tag SAM head. It's a 21 centimeter across head. Inside of it, you can see that there's this weird shadow. That's a piece of rock that jammed itself into the mylar flap that was keeping the rocks inside. And so we saw lots of regolith escaping, and every grain loss is a PhD not written. And so we had to quickly and painfully lock this TAG-SAM head into the sample canister. This is a one-time only maneuver because we have to sever the head. And this was all done lockstep by lockstep slowly with that 40-minute round trip communication with the spacecraft to make sure it was lined up just right. 2 years later, we got back to Earth, and here's the ejection of the sample return capsule. It goes by pretty fast. I'll show it again. So here's the Earth. Up on top is the sun. So it's really bad angle for taking images, but more important to get the sample back. So here is the bottom of the sample return capsule being ejected with that being visualized by that same sampling imager that we had looking at the surface of Bennu. And the spacecraft went on its way towards got stuck towards orbiting the sun and towards Apophis. The sample return canister descended through Earth's atmosphere. It tumbled, and then the drogue chute failed to deploy when expected, but the main chute deployed, and it descended perfectly because the main chute had plenty of margin, and landed conveniently right next to the roads. The helicopter didn't even have to get its skids dirty. I don't know what's wrong with that. So the capsule landed. We made sure it was safe, that the batteries inside were not on fire. Documented the area just in case there was a breach, so we could understand again that chain of evidence of the sample. Bagged it, secured it, flew by helicopter on long line to a hangar at the Utah Test and Training Range in Utah, where all this happened. Where the capsule was opened up, that battery was removed. The following day, it was flown to Johnson Space Center in Houston, where the next day it was opened up. Another thing that happened, why was chemically reactive nitrogen used in non-noble gas? Nitrogen gas is really not reactive at all. And nitrogen gas is what Johnson Space Center uses routinely for their curation. And so we picked the same gas that JSC has been using since the Apollo days to handle their samples. So since the samples are going to be stored in nitrogen gas anyway, that's what we use to stimulate the regolith and extract it. And so here it is inside of a glove box where some fasteners got stuck and were later removed to free up all of the sample inside. Again, in this nitrogen cabinet to make sure it doesn't get moist. We needed to bring back 60 grams from Bennu, and we're able to return 121.6, even with all the sample we lost in space. Of that, about a gram is on the avionics stack out here, and then here's the sample canister, which when those bolts got stuck, the curators were able to scoop out lots of material with 70 grams. And then later on, when they designed the new tool to unstuck those fasteners without causing them to shred or cause contamination within the glove box, we're able to get another 50 grams. The rocks are, at least they were smelly. They smell like sulfur, gunpowder, and burned marshmallows. They're really dark black. They look like coal or fresh asphalt, with some lighter bits here, and some shimmery particles. It's kind of pretty. The powders stick to everything, both from being electrostatic because they're so dry, but also they're sticky with organics. Some are angular, like these, and some are hummocky, that is cauliflower shaped, with a variety of densities. It's also amusing that the morphology is reflected from the centimeter scale to the meter scale. So here is a giant rock on Bennu, um, 30 meters across. That is a sort of a similar shape to this angular piece, a centimeter across, as well as these hummocky pieces that look like these hummocky pieces. And so the crystal structure is reflected in both the meter and sub-centimeter scales, which shows us something about the geology. The sample has been distributed. The 121.6 grams of sample plus these contact pads, 24 of them that touch the surface of Bennu and collected surface dust. 0.5% has gone to the Japanese Space Agency in exchange for material from the Hayabusa 2 mission, as well as information on their sampling event. The 4% went to Canadian, or is going to the Canadian Space Agency. They don't have it yet. In exchange for that, the LiDAR instrument that gave us the great shape model of Bennu. Up to a quarter is going to the science team, though we only have time to analyze 14% of it, looks like, in the labs all around the world, leaving 70% remaining. So that scientists around the world, and even those not yet born, can use their own ideas, their own techniques, and request sample. And so here are QR codes for the sample catalogs for JAXA and for NASA. So you can write your own proposal and get your own samples and test your own hypotheses. And these will be around for a long time. So for example, there's about a 7-gram sample that has been put in a minus 80 degrees freezer. That's, I think, like minus 110 Fahrenheit for another 49 years. And so 50 years after collection, our children or grandchildren could have new ideas and new techniques that they can ask the samples themselves, and these will be stored frozen so that they're unchanged in all that time. Yeah, so as I said, you can look at these samples from techniques, some of them as large as the launch pad, some of them fussy and difficult, all of them ever changing and ever being improved with the best minds around the world. Again, some not yet born. But the science team themselves are asking, we have 54 hypotheses broken up in 12 categories, which can be binned in 4 different segments. One is, how does the sample compare with the observations from Bennu? That is, are our spectrometers interpretation accurate based on what we see in the ground truth of the sample? Does a sample contain organic compounds related to the origin of life, perhaps? What does the sample tell us about the history of the solar system? And finally, how's the sample changed since we collected it? And so at Bennu, we're able to observe and see that it resembled these CI and CM type meteorites. And then when you look at the sample close up, you can look at, say, here's the elemental distribution of fairly non-volatile elements compared to CI meteorites. That's what the one line is. And Bennu is very similar to CI type meteorites, as is, of course, Ryugu. Very different from CMs up here in the squares. And so it is, in fact, a CI-like meteorite. That's a very primitive one with a very solar-like elemental composition. We also observed in space polysilicates, which we see in abundance on the sample, as well as iron sulfides, as well as magnetite, as well as carbonate. So we have a very good track record of correctly identifying these minerals from space and then in the laboratory. We determined that it was hydrated with at least 1% carbon, In fact, it's closer to 5% carbon when analyzing the samples, and quite a lot of water, up to 1% hydrogen by mass, and a very large amount of nitrogen. A 1/4% is a lot of nitrogen for these sorts of samples. On Bennu, we observed xenoliths, that is, pieces of other asteroids that landed on Bennu, look like bits of Vesta. Those have not yet been seen in the sample. However, those white bits are phosphates that we saw, which were not predicted from the instruments in space, because phosphates don't have good absorbance features distinct from these other minerals, and so we really had a sample on the ground to tell you that they were present. We observed that the sample contains organic compounds. So here is nitrogen versus carbon, plotting a number of different types of meteorites, asteroid Ryugu and asteroid Bennu. You can see on this plot that actually Bennu is quite different from CI type meteorites, although they also have a similar ratio of carboxylic acids to amines, and very different from Ryugu, even though they look like they come from similar places in the asteroid belt. Their organic distribution is quite distinct. We've compared the isotopes of nitrogen versus deuterium. Bennu is clustered right here, and Ryugu is quite distinct, as are CI meteorites. So even further away from looking like CIs in terms of nitrogen and carbon and deuterium, or hydrogen. So although the metals look like CIs, the organics don't. They look, if anything, closer to these C ungrouped meteorites, like the Tagish Lake meteorite, and very distinct from CRs and CMs, which were other hypotheses that are bouncing around. We also, there's a lot to see on this graph, so don't worry about it so much, but we see that there are over 16,000 different nitrogen-containing formulas. So a large variety of nitrogen chemistry, more nitrogen chemistry than sulfur chemistry, which is seen in Ryugu and Murchison. And of this nitrogen chemistry, we saw a lot of ammonia. So here is the ammonia extracted from Bennu, which is higher than most other meteorites, much higher than Ryugu. There is some the 3 reports of Orgay that is the CI, 2 are high, 1 is low, and then there's this weird CR that has a high abundance, although the extraction techniques are different. But you might be asking yourself, didn't Osiris Rex use hydrazine monopropellant? I would say yes, it did. And as we all know, when hydrazine monopropellant is fired, it disproportionates into ammonia, nitrogen, hydrogen gas. So how do we know that this ammonia we detect on Bennu isn't just pollution from our own spacecraft? Well, in 2016, we took a sample of the propellant from the spacecraft as it was being loaded and measured the isotopic ratio of this fuel. And it is in this weird scale, it's +4 versus +180, and that's a huge difference. So that the ammonia we detect in Bennu cannot have come from or at least not predominantly come from our own pollution from the thrusters. Sorry about that. We also looked at the amino acids and further saw there's a lot of data here. Don't worry about it so much. But these are ratios of different amino acids, and you can see that Bennu has this high, medium, low, lower trend of these 4 different amino acids, which is very different from Ryugu, which is a low, very high, medium, and low, which is similar to Orgay, that CI meteorite. However, Bennu is somewhat, again, like these C ungrouped, like Tagish Lake, and maybe a little bit like Winchcombe, this weird CM meteorite. And so again, the soluble organics are telling us a different story from the metals. And so it is a very confusing piece of rock. The one tells us we went to the right asteroid because it is different from anything we've seen before. It also tells us that just mineralogy and just elemental ratios is not sufficient to understand the complex history of such an object. We also detected all 5 DNA and RNA bases, as well as a whole bunch of other nitrogen heterocycles, and a large suite of amino acids, including 14 of the 20 protein amino acids, though all of them are racemic, equal amounts of left and right-handed amino acids. And these were just published. This and the previous results were just published in Nature Astronomy a few weeks ago. Open access. You're welcome to read that. So we can look at moving from organics to solar system history. We can see from looking at neon cosmic ray exposure ages that the sample we got from what was on Bennu surface for 1 to 6 million years. So it was a relatively fresh crater, as the spectroscopy hinted at us. At the same time, we also see that there are silicon carbide and graphite grains that are older than the solar system. So these yellow diamonds are grains that came from supernovas or red giants prior to solar system cloud formation. We can also look at the mineral compositions close up on Bennu and realize that there's a range of evaporites, of extremely late stage evaporites. So when you have a salty body of water that dries out, these are the last solids that fall out of solution. This is in a paper that also came out the same day, is also open access. So sodium carbonate, this is the mineral trona, and the hand sample looks a lot like the microscopic sample, as well as sodium fluoride. Again, and this was initially thought to be a contaminant. We did a lot of searching and realized, no, it's just a weird mineral that hasn't been seen in a meteorite before, and would have been assumed to be contamination if or have been lost due to exposure to air on the surface on the Earth. And these point to very late stage aqueous alteration in alkaline basic environment at modest temperatures, unlike all that ammonia, which points to very cold temperatures. And so it tells us of the evolution of this asteroid from a very cold object to a temperate object, but never got hot and was extremely wet. And so this opens up questions about, well, where did it come from? Is Bennu a dead comet, or was it ever a comet? There's this comet slash asteroid Lowson-Harrington, which is also a Class B asteroid of the same spectral type that sometimes forms a tail. If it's a comet, that it checks the box for being undifferentiated, that is having the CI like the solar-like distribution of metals, very salty, very cold, consistent with the ammonia. But there's minimal rock water interactions, so the clays don't make a lot of sense. The ammonia makes sense, and the ices make sense. Or is it like an ocean world that we've seen? But these are differentiated so that they melted to form a core, which Bennu's parent body never did, but also checks the box of salty, cold, water rock interactions, ammonia, and wet. So there's a lot to try to piece together about how does Bennu fit on this continuum from icy to wet. And finally, we were looking to see how the sample changed since collection. And so here's one case where we have bits of rock that you can puzzle piece together into one that broke up either on the violence of collection or during landing on Earth. We don't know yet when that happened, but work is in progress. And to finally I'll remind you that the spacecraft and the team went through a lot. Much of this is common. Others are rare, and you wouldn't expect weird things to happen. And that we came through this together as a team, and it's been a remarkable journey. And I thank you for your time and your attention. And you can learn more at these social media sites, as well as looking at the sample catalog to look at all the pictures of the sample and perhaps come up
David?
with their own ideas for analyses. Thank you.
Cool. Thank you so much, Jason. A lot of really cool things that you found there. Um, does I think we got a time for a little bit of time for some questions. Is that right, Jason? Yeah.
Yes, yeah,
Uh,
as much as you need.
Perfect. You got any questions? Answer.
Why was it throwing off small rocks?
All right.
That's an excellent question, and we have at
Yeah.
the Astro we had two hypotheses about that.
Yeah.
One was that there were micrometeorite impacts.
I
Um,
don't,
the surface of Bennu only experiences a few micro-Gs, not much more than on the International Space Station. And so a small impact would create a series of events that cascade and rocks get thrown off of the surface. Um, that's one possibility. Though also, as we're seeing all these volatiles, the other possibility that there are warming and cooling cycles
I'm sorry.
that as the rock dehydrates or loses volatiles, it cracks. And again, it's this very low gravity environment. So when a rock cracks, it would also release a shower of particles. And this has presumably been happening the whole time, or at least since it roughly dried out. And that also gives us an idea about the mechanism about how those other xenoliths, the pieces of rock from asteroid Vesta, or or a Vesta-like asteroid, got onto Bennu from this exchange from asteroid to asteroid.
Oh, okay. Now a minute. Let's see. Probably so. It started at 7th.
I think Joe's got to
Correct. That's a presentation by the
uh,
man who took
let
what?
me mute Joe real quick. All right. So I got a question for you. At the beginning, you were mentioning, you know, being able to chase a few asteroids to the meteorite stage. How big were those in order to come through, right? Like to be able to track them and then find them. How big was that we were talking about?
So I think Alma Hastacita was sort of the size of a desk, say 6 feet across,
Gotcha.
and it was observed just a few hours before it hit the Earth, and was seen in a European weather satellite as a fireball over Sudan, and then it landed in a location that's all sandy, so it's relatively easy to find once you have coordinates.
Yeah.
There was one that landed in Germany recently, and another one in Botswana in 2018. And then, of course, there are others that were detected that land in the ocean, but that's much harder to find an asteroid that's on the bottom of the ocean and that's impossibly contaminated.
Yeah. That's interesting. How often do they find asteroids of that size, I guess, seeing as how big space is and, you know,
Asteroids I think that's fairly rare. I don't know the statistics on asteroids of that size. I know that there have now been 3 asteroids detected that then became meteorites.
yeah. Let's see. So I got another random question for you. I know that whenever you landed on Bennu, you didn't expect to sink as far as you guys did. Yeah, I know you guys were in a controlled, no, not controlled, but I guess not falling at a super fast rate, but you were still kind of falling. Um, have you guys looked to see if you guys altered the orbit any or
Oh, the orbit, no. We wouldn't have altered the orbit. It's well, one actually um, uh, the energy was absorbed by the surface of Bennu from that impact. Um, but the Bennu is the size of a large hill or small mountain, a half kilometer across. The spacecraft is the size of an SUV, and the spacecraft was moving at 10 centimeters per second, which is the speed of a of a rather slow infant or a very, very fast snail. And so it didn't impart a whole lot of energy on the surface. So it wouldn't have moved Bennu. And in fact, when we went back to Bennu, we didn't have to make any course corrections or adjustments. We went back to take this data after the tag. It was not like the impact events on by the DART mission that was a much smaller asteroid and totally destroyed the spacecraft that hit it on purpose.
Yeah, that was a really fast snail.
Yeah. Yes.
Let's see. There's
Oh,
a question.
specific rock that jammed. Yes, we think so. Let's see. We think it is this one. This is a 3D printed model of it. Oh, and actually, this one right here.
Hmm.
This grayish one. We think that's the one. And that one is different from all the other rocks. It also bits that broke off of it. It has all this white stuff on here, which is probably the phosphate. Actually, it is the phosphate, but we're working on that. And so when that happened, I said to myself, the rock that jammed it better be worth it, worth all the sample it lost. It looks like maybe it was.
Except for all those PhDs, you have to tell them it was worth it.
Right. So now this is, and if you want to go to the curator website, it's OREX-8 00014-0 is the name of that rock.
It's catchy.
It is. There's a whole nomenclature system, but yeah, it's 14. It's that one.
Gotcha. Sorry, I have another question for you on the biology kind of side of it, biology and chemistry. As far as you mentioned all the variety of amino acids you guys found. Of the ones that you didn't find, was there common chemistry of those that you didn't find versus ones that you did that kind of would give an idea of why you haven't found those, or are you still just kind of searching to see if you can find them?
Some of them are not very stable. So like actually we did find the asparagine, which isn't very stable. These are all basic amino acids. Maybe that has something to do with it. Um, Tryptophan and histidine are tough to make
Yeah.
prebiotically. So maybe they're not there. The total amino acid abundance is lower than we had hoped, lower than our than either what we see in CI or CM meteorites. And so that makes the analyses more difficult because there's less there, and with the same amount of sample. But we've seen so far every amino acid that's been seen in a meteorite we've found in Bennu, but no amino acids that have never been seen have been detected. And
Gotcha.
so I should say of the protein amino acids, there's about 90-ish amino acids that have been named in meteorites, with hundreds observed, but only a peak, not a name, or only a mass, not a name. And some of those are at very, very low concentrations that would require many grams of sample to destroy to get at. So those are not going to happen. In the
Yeah.
case of some of the meteorites, people did take 20 grams of sample and crush it up and destroy it to get those numbers, which is not an option when we only have 120 grams. Not
Yeah.
worth it.
Understand.
So that's better to wait for technology to catch up.
Yeah. Real quick, while you're on this slide, I know there's another question in chat. Just real quick, was there interesting ratio of thymine to
I lost
uracil?
you.
Oh, sorry. Can you hear me?
Yeah, you're very staticky, but I can hear you.
I'm sorry. Was there a ratio,
Yeah, now you're
an
silent.
interesting ratio? What's that? Can you hear me?
Sometimes.
Oh, gotcha. Hang on. I'll type it in chat.
maybe type it. I'm not sure. The as far as oh yes. Oh, the ratio of thymine to uracil. I have to look that up. That's in this manuscript right here. I've got to read it again. I wrote it, but I don't remember. Um, however, I can say for certain that they did not publish Targaf rules. So the ratio of adenine to thymine plus uracil is not equal, and the same thing with the ratio of guanine to cytosine. So we can say that it's not contamination. Um, let's see, theories as to the shapes of the rocks. That's small rocks versus big rocks. That's reflection in the crystallography, and so the minerals packed together and express the same shapes at different scales. And because there's essentially no erosion, it's that shape is free to express itself. At least that's what the mineralogists tell me. I'm an organic chemist, so I can't say for sure. And then at Apophis, it's not actually a tag, well, it's an air tag. There is no tag arm left. So if you go and look at we'll go way, way back. If you look at the spacecraft, here, the collection head is gone. That's on Earth right now. And so there won't be a sample collection. This arm will be stowed in its holder here. We don't want that flopping around. And this convoluted tube was cut, and so we don't want that flopping around and possibly doing damage. So this will be stowed, but it'll be the main thrusters that will fire, and or not the main thrust. These backaway thrusters will fire. Um, I guess I don't have a good picture of that. It's a part of this movie. Whatever. Yeah, so instead of having the central divot from the gas being fired, it'll have four jets of propellant that are shot out as it's close to the surface of Apophis, so that it would make uh, not it would make these thruster marks, not the central crater, because the spacecraft was designed to get one sample and one sample only. Um, Not multiple ones. So that's not an option anymore, but they can fire the thrusters and see what that does and then do calculations on the cohesion of Apophis compared to Bennu. And that would be useful if we need to ever divert Apophis, because that's also a potential asteroid impact hazard.
How big is Apophis?
But as far as how deep it goes, I don't know. That's the science.
Gotcha. Can you hear me?
Any other questions? Or are we out of time? Oh, how big is Apophis? Boy. Okay, so first of all, I'm not on that mission. I follow the sample. I'm not on Osiris Apex. Um, I'm on still Osiris Rex. So I'd have to Google that for you. And it is 450 by 170 meters in size. So it is about the same in one dimension and about less than half in the other dimension.
Good deal. Can you hear me?
A little bit.
Gotcha. I don't know what's going on with my audio. All right. Is this any better? Not really.
Only when you ask if I can hear you, nothing else. Can you hear me? Silence and then not really. That's really weird. You were fine before. So I guess it's just me. Well, I'm not really accustomed to Zoom, because that's not a NASA platform. Steve, you want to repeat what Tom is saying? Would that work?
Ha! How about now?
Okay.
Oh, gotcha. Um, yeah, very, yeah. Who knows what's going on? I just want to say thank you
There you're
for
going.
coming and giving us a talk. Um, and it's out
Sounds
again.
safe.
Um, let's see.
Well, Terry can hear you. I don't know. Terry, do you want to repeat what's okay? Well, thanks. Glad you
Well,
enjoyed
thank you,
it.
Jason.
Thank you.
Looking up. Oh, and you can look at samples yourself if you're ever in Arizona, in Tucson, in Smithsonian, Washington, D.C., or Space Center, Houston at Johnson Space Center. There are samples on display. And of
Well,
course,
that's really
curator.jsc.nasa.gov and look at the pretty pictures yourself.
perfect.
Thanks
Well,
for
thank
having
you
me.
very much. Yeah. All right, bye, guys. All right. Let's see.
Enjoy the rest of your meeting.
Yeah, thank you. Have a great day.
You too.
All right. Can you guys hear me? Yeah.
Yeah.
All right. The other day when we were in a board meeting, my laptop's, or my microphone cut out then. So, uh, well, let's see. All right. So I'm going to fire up my talk for today. Give me just a second.
While you're doing that, Tom, I know he's mentioned that video that he showed the beginning was on NASA Plus.
Yeah.
For anybody that doesn't know, if you log into the Night Sky Network, up at the top there's multimedia, and you click on that, and NASA Plus is on there, and it's one of the first things that comes up.
Oh, that's awesome. Yeah, because I don't know, the audio wasn't didn't go very well on my end. So that's really cool. I'll have to check that out. Um, maybe we'll have to share that um, on the Google groups and maybe on Facebook or whatever to kind of get the word out. It sounds pretty cool. Every time I hear him talk about that mission, you know, all the things that can go wrong, there were quite a few of them that did. So, but they were still able to work through it. Can you guys see my screen shared?
Yes.
All right. All right. And Tony, since you're chatting, if you catch my mic cutting out, holler at me so I don't sit here and talk uh, to my computer for nothing. All right.
A loud holler, a mid holler,
Well,
or
whatever you're doing right now, I hear just fine.
okay, so a low.
Yeah, yeah, you're good. All right. Well, thank you everybody for coming today. Those of you who are sticking around for the important stuff from the club, thank you for that. We've got a few things going on today. Hopefully you enjoyed the talk. There's a lot of really cool science coming out of that, especially as a biology person, seeing all those amino acids and nucleic bases and stuff like that. Like my brain just goes, ooh, aliens. But obviously there's going to be more and more to that. But well, thank you very much again. I'm Tom Beckerman, the current president of BSAS. This is our February monthly meeting for 2025. We normally meet at Dyer Observatory, but the snow kind of pushed us off of the hill today. Couldn't even get up the hill, I'm sure. So hopefully next month weather will cooperate. We're still in the groundhog's 6 weeks more of winter. So either it's his fault or Tony's fault. So let's see. We had Valentine's Day a few days ago. So nice picture of the Heart Nebula taken from the Hubble. Here you see, I did some imaging of the Heart Nebula, and I need a lot of processing to even come close to something like that, but it's pretty. And so we'll see another couple images of the Heart Nebula a little bit later. So we'll go ahead and call everything to order today. Hopefully everybody had a chance to look through our BSAS magazine or our newsletter for the minutes from last month, both board and member meetings. Anybody have any questions in regards to the happenings of the club? All right. We're good there. Is Keith in? I don't see Keith on here. As far as members, I checked a little bit earlier, and I think Keith sent out an email. We're at 228 members, so climbing little by little. I've been keeping a little tally of members since I started actively recording in September of 2023, where we were at 159 members. I think that was when we first started really kind of getting back into things, and so numbers have been climbing every month, and so it's exciting to hopefully get more people involved with an interest in the sky. Show everybody that there's a lot of cool stuff here that we can look at. Theo, are you available for a treasures report?
Yep.
All right, go for it.
Shoot. Now I just click back to here and hang on. Let me exit you out of full screen. So we have a little bit of money. Right now is $9,346.06. And all we really did since the last member meeting was I got reimbursed for the meat and drinks and stuff for dinner. We paid for the Zoom account, and we paid for the Natchez Trace permit. So that's pretty much it. Right now in PayPal, we have nothing because, let's see, a week ago, I moved the whole kit and caboodle to the bank. So we'll start building that up again as people pay. And
membership.
Social media, we've got Facebook liked by 2.3K and followed by 2.6, and Twitter is hanging at 324.
Good deal. All right. So moving on, some of the business to just talk about today. First off, the next member meeting is a month from today, March 19th. It'll be at 7 p.m. At Dyer Observatory in Theory. Hopefully also be streaming over Zoom as long as I remember to hit the button. Theo will grace us with her presence and tell us what's up in the night sky. But also next month, towards the end of the month, we have our planned annual Messier Marathon. And so we're hoping to get a little bit of a blurb about maybe how to go about a Messier Marathon, what it is, different strategies and things like that, when to sleep, when not to sleep, stuff, all sorts of things. So if you've never heard of a Messier Marathon, there's a lot of really cool things to see and talk about. And basically you're trying to catch as many Messier objects in one night as possible. And so I know I've been to a few when we haven't gotten rained out, and as far as hunting and finding things, it's always exciting.
There was a
ahead.
particularly disgusting recitation of somebody's Messier Marathon they did from La Palma, the island where there is an observatory. Anyway, it was really disgusting because they had to look like through the zodiacal light for the first few objects. And I'm just feeling their pain on this. Anyway, they actually did all 110 in the night. So, yeah.
People just have all the luck, right? I mean, it must have been horrible that first little bit, though. Yeah. Yeah. So, as far as Star Party locations, we're still filling out. I'm pretty sure we have the majority of our schedules set. If they're not on Night Sky Network, they will be soon. But I'm pretty sure they're starting to show up. But if anybody has any Star Party locations that they'd like us to start checking out, we can look at those. As well as I know I've seen a few emails and messages about potential speakers and topics. And so if anybody has any interesting things that they want to hear about, let us know. And so we can start searching people out, because if my brain serves me right, speakers that have been selected so far this year end at Theo next month. So we've got a whole year of speakers to find. So I've got to get on that. So if you have any thoughts or ideas, let me know. All right. Just real quick, I wanted to say thank you to all the board members that help run this show. Over here on the left are our officers, and over here on the right, directors. We've got a really good core, and we're getting a lot of stuff moving. So hopefully you guys are enjoying your time with BSAS as members. And if you have any questions on anything going on with the club or any suggestions, feel free to reach out to any of us on the board, and we can at least get you headed in the right direction. If there are any new people here, or if you're following us on YouTube, you can find us at bsasnashville.com. We typically go through here, and I kind of highlight some of the cool things on our website. One of the cool things that we have is this Hatch Show print that was put together for our 90th anniversary a couple years back. If you collect Hatch prints, it's a really unique item. They built this stencil here for us. It's 20 if you buy it in person, 25 if you would like Theo to ship it to you in a nice tube. It's a pretty cool print. As far as our website, there's a lot of really cool, really neat little features, one of which is this Nashville Clear Sky Chart. I snagged this screenshot earlier today, and you can see white is bad. And so kind of in pattern of what happened today and last night, we're still in clouds. However, it looks like tomorrow night might be decent, maybe Friday, but who knows what all can happen and change over a little bit of time. But it's a really cool little tool, that Nashville Clear Sky Chart, where you can kind of get an idea of how good the seeing is before you lug all your 10-inch Dobbs and your C14s out to whatever site you're going to. Also on the website, if you're interested in becoming a member, there's a little tab here, a little link that you can click to become a member. That'll take you to this, where membership gets you a copy of the Eclipse newsletter sent digitally to your email. There's discounted subscriptions to Astronomy and Sky and Telescope. There's membership in the Astronomical League, and they send out a newsletter as well, their journal, the Reflector. We do have riveting BSAS elections that you can vote in, and you also get access to the private star parties, which we hold once a month. And down here, you can create an account with Night Sky Network, which I'll talk about in a couple slides, and then pay through PayPal. You can see there that individual cost is 25, but here's the list of all of the total. So you can get a family membership for 35. If you're a student, 15, and senior family is 20. So we've got membership options that'll kind of cover whatever group you're in. I just wanted to also mention up here in the upper left corner, I've gone QR code crazy because I feel like trying to remember a website address and whatnot is a little chaotic. But if you use your phone in any of these slides, you probably be able to tag that QR code, and it should take you right to our membership page. And so, if you have any questions on any of these, you can go to that QR page or send us an email. We'll talk about that in a bit. One of the things of value of the becoming a member is that we have a loaner equipment program where we have a host of telescopes that are available for borrowing to our members, where that's just kind of included in your fee. And so there isn't a cost for you, but this is one of those use it before you buy it kind of things. So do you think you could lug around a 10-inch Dob? Or do you need something smaller? What are you going to use? Because that's obviously the best telescope there is the one that you actually use. And so if you're thinking about buying one, check our site. I think this is the direct link to our list of scopes that we have. I do need to update it because we have a few. We got a few at the end of the year that I haven't put on yet. But you can check that out. It's on our Google Groups link as well. And let us know, if you actually have a scope that you're borrowing from us, keep us in mind and let us know how things are going. If you have any questions or you're like, man, I wish this was a little bit better aligned or doesn't seem like the collimation's in check, we can help out with that. Also, it'd be great to see you guys out at star parties or out with the public to, share the love for the sky. And so, star parties are also great places to, if you're trying to figure out how a scope works, there's a lot of really good knowledge that's sitting there, working with scopes, and they can probably help out as well. And finally, if there's anything we can help with in terms of you enjoying the scope a little bit better, just reach out and grab us. Back to the website. I showed this the other day and it still amazes me. The reason why I'm showing it again is because we just got updated. This link to the clips, you can see here that there's digital copies. This is all of last year, all the way to 2021. And then if you go all the way back down to March of 2001. So 24 years of the clips is stored digitally on our website. And so one of these days, I'm just going to start digging through because it's like a little time shot or time capsule of things that were going on back then. So it's a pretty cool resource that we have available just through the website. We have a handful of social media accounts. Theo mentioned Twitter and Instagram. Kind of going through those, or not Twitter, Instagram, but Facebook, Instagram, she mentioned. This is our Facebook account. We're BSAS Nashville on Facebook. The QR code will take you to our site. This is a most recent post here. We're promoting a talk about the James Webb Space Telescope and looking at some of the data that's coming from it because it's been around for a little bit of time now. And so the data that's coming from it is absolutely amazing. And so hopefully that talk will be pretty valuable. So if you're interested in that, go through there. That's next Tuesday. On X/old Twitter, we're not super active on that, but we're getting there. We're starting to pick things up, but on there you'll find really important event notifications and stuff like that, like February 1st, where unfortunately we had to cancel a star party. And so it gives access to upcoming events and things like that, and any important notifications will be posted there. On Instagram, we can highlight pictures and stuff like that. We've got a lot of pictures coming through the Google Groups right now. I'll talk about that in a minute. And we love that you guys share your pictures of the sky with us. And so if you have any pictures you'd like us to share, just let us know. You want us to post it on Instagram. If you would like us to do that, or if you really want us to do that, send your Instagram handle so we can, give you credit for it. You can send your pictures to info@bsasnashville.com or post in the Google Groups, and we can get you put online. Here you can see a couple really cool images, and I just wanted to highlight the one in the upper left. There's a Severe Weather Awareness Day that's on Saturday, and BSAS will have a booth there. So if you're interested in weather or seeing one of our BSAS members there, talking to them about the sky and things to shake your fist at when you can't see stars, the Severe Weather Awareness Day is pretty good for that. All right. And on Google Groups, this is how a lot of the members will communicate with each other. If you don't have access to Google Groups, let us know. It's an invite-only group. And so once you're a member, we can add you to this. And so if you're a member now and you would like access, send us an email. There's a lot of things that go on here. First, I wanted to mention that of the 228 currently on our roster, 155 members are currently there. So there's about 70, about 70 members that don't have access to it. And so, like I said, if you're one of those members that would like access, there's a lot of good value here, a lot of good things. For instance, here's a link to our Natchez Trace permit for the year, so we can go out there for our dark sky sites. There's a link to our equipment list, and I was going to ask Keith if he noticed it, but like for a while there, you couldn't pin anything at the top of Google Groups anymore. So that's why I put the links for the permit and the equipment list here. But now they're allowing us to pin these. And so this is the conversation with the permit. Keith, I'm pretty sure, pinned the group rules for the Google Groups. It's a closed community, so we know where we can find people if needed. But there's also star party etiquette and guidelines. And so if you're wondering what a star party is and, what there is to do and things like that, uh, it's a good little reminder to go through that every once in a while. Also on here, like I mentioned, people are posting pictures. This image was courtesy of Bud, our current secretary, of the sun a couple days ago. You can see some really awesome sunspots. It always amazes me every time I see sunspots through a little scope, obviously with a good filter. But the fact that you can actually see sunspots, it's pretty amazing. And Bud does a really good job of sharing pictures of the sun. This was a couple days ago, or a couple days before this one, and whenever we rarely get to see the sun, but you can just see how much the sun changes, and it gives an idea of how dynamic our little sphere of light is, and it's pretty cool. On here, a lot of people share a lot of images, and part of being in the Google group is that you have access to these images. And so if you really like pictures of cool things in the night sky, it's kind of the place to be. This is just a smattering of the images that showed up since the last member meeting. And so, like I said, we've got some really talented imaging people with imaging skills here, variety of Rosette nebulas and Triangulum galaxies, Mars. So there's a lot of skill in the group, and I just wanted to highlight this one in particular. Jeff Horn, I don't think he's in today. He's a member, been for a while. He actually got an APOD in December, and so if you're not familiar, APOD is Astronomy Picture of the Day, and I was trying to tell my wife, it's kind of like the peak, like this is what you shoot for kind of thing. And to give you an idea what it took to Jeff to get his APOD, this is the Heart Nebula. I pulled some pretty cool stats off here. 405 hours and 22 minutes of integration time, and I'm pretty sure those last 2 minutes were precise, right? Like you needed those last 2 minutes to get all this data out. It is amazing. And if you're doing the math at home, like I know you are, that's looking at this over 57 nights. And so he recorded a lot of data in order to get this together. Not to mention the processing that has to go into all of this. And so kudos to Jeff, when putting this together. And to make this even more interesting, his skies are Bortle 8. So, in Nashville, there is, possibility of doing something like this. And this is just a screenshot. I picked this one up because let's see if it'll go. This is kind of like the full blown up version. If you're wanting to look at this on AstroBin, the QR code up there will take you to this image. The more I look at it, it's just, it's spectacular, seeing all the different colors and shapes and intricacies of our sky. So well done there. Speaking of AstroBin, if you post on AstroBin or share pictures on AstroBin, let us know. We've got a little private group for BSAS members to share images with each other to show, so we can follow each other and see what everybody's doing. I think there's about 12 or 13 of us in there. I haven't posted many because I haven't had much time, but there's a lot of really, again, like I said, talented astrophotographers there. If you're interested in things like astrophotography, it doesn't take much. All you gotta do is point a camera up and set an exposure for a little bit longer than normal, and you'll be surprised at what you can catch out of the sky. Now, obviously, astrophotography is a lot like, you know, being in love with astronomy, and it'll take as much money as you want to throw at it. But this is how I started, with little DSLR pointing up. Now I'm sort of here. I'm working my way to here. I've got a little portable automatic scope, but you know, astrophotography is really fascinating, and you know, everybody gets into it for a certain reason, one way or another. But if you're interested in astrophotography of any type, you know, reach out, because there's a good chance that somebody in the group has gone through your growing pains as well. So it's a really cool hobby. Now, as mentioned in the Become a Member slide, we run our membership through the Night Sky Network. And so if you wanted to become a member, so if you're seeing this on YouTube, or you're a guest on the Zoom session, you would come to Night Sky Network. You can grab the QR code for that. It'll take you to our site. You'd sign up there, and then you go to PayPal and you'd submit it, and we'd see your application in Night Sky Network, and we would add you to our rosters, and you'd be official. So Night Sky Network is a really good source for us. I just added our Facebook and Twitter or X account here, so you can get to those socials as well here. But you can see on the right there the upcoming events. Here, our monthly member meetings are showing up, and the public star parties. And so you can see here that March 1st, we have our next public star party at Bell's Bend. And so, you know, it's a really good place to see our calendar and get some information about the club. Night Sky Network is also a great tool for information, and so they post a lot of really good articles, and kind of near and dear to Theo's heart. The monthly article for February is how can you help curb light pollution, and you know, we've been fighting against the illicit use of lights for quite a while now, and Theo's kind of taken that charge and running with it.
Literally, ask me how.
Just a second, Theo. We will. So here in this article, they link to the darksky.org. And so if you're interested in this, you can check out this website, you know, who we are, what we do, how you can get involved. In there, there's also a link to TennesseeStarrySkies.org, where if you see this image here, take a look at who it's credited towards. And if you do some digging in the about Dark Sky, Tennessee, you'll see that the president is in our midst. Theo, would you like to add a few words to that?
Well, you know, somebody had to do it. So a couple of years ago, actually, a lady out in Memphis who was kind of trying to do a West Tennessee thing. Anyway, the Dark Sky International people wanted to go to a model where we had just a chapter for the whole state. And they're getting all the states organized like that. So she contacted me because I was kind of on the list from Ancient of Days. And so anyway, that's what we chartered as the Tennessee chapter. And you're a member of IDA, then you are a member of our chapter. That's how that works. We don't have separate membership lists or anything. So we're just kind of getting organized. We have a president, vice president, a treasurer, and a secretary, and we're going to start expanding the board. And hopefully my plan is to, inside the next year, have some kind of a public, you know, meeting or thing here in Middle Tennessee to say, hey, everybody who's interested, and we can spam that out to all the people that are Dark Sky members. So, you know, to do some kind of organizational meeting with what can we do here in Middle Tennessee and how should we do it? So we'll work on that. There's a lot of cool resources coming online. Dark Sky has reorganized their website. You can go if you want to know what the research is in different areas. They've got a whole searchable database where you can find out a lot of cool stuff about, you know, ecological effects, safety aspects. There's a whole section of people that are sort of working on something you would call light justice, because it turns out that wealthy suburbs have fewer street lights than downtown or projects, let's say. And that's because it's a couple of reasons, but people have this weird perception that being lit bright as day during the night makes you safer or somehow deters crime. And it actually doesn't do either of those things. But anyway, there's lots of cool stuff. And of course, I'll have some information at the table at Severe Weather Awareness Day, which come on out in the morning. The morning is fun. You get to go to the booths. And let me tell you what, the TV stations bring swag, cool swag. We've gotten everything from umbrellas to last year, I think it was News 2, had free weather radios. So lots of good swag.
Where's this at, Theo?
It was channel 4, Theo.
Oh, okay, sorry. Thank you, Tony. Tony comes out and hangs out with me.
Theo, I've been going there 10 years longer than you.
Well, you know, I defer to your senior expertise here, and
but who's counting?
But it's really nice. Nash Severe Weather is there. A lot of the EMAs come. The group from the meteorology kids from Western Kentucky come on down. So there's a lot
of
cool stuff. Trevecca.
It's at Trevecca. And what time does that start?
I think it starts at 9 a.m.
9 a.m. Gotcha.
And the morning is the booths. And then the afternoon, there are cool talks by our local meteorologists and National Weather Service people.
If you're heading to Trevecca, are there good signs up that point you in a direction?
If you go to the National Weather Service, Nashville's homepage, there is a link for SWAD.
Okay, SWAD. Everybody's got an acronym these days.
Oh, yeah. Awesome. And it's absolutely 100% free.
Yeah.
Unless you're a news company giving out radios.
Right. And umbrellas, or let's see, we came home with what's the little icon for one of the stations that's like a penguin or something?
Oh, the weather bird thing.
Snowbird.
Yeah. So Snowbird, that's right. So there's just all kinds of stuff. I don't know if Ali will be there this year, but that'd be fun if he was. But anyway, it's a cool free event, and you can come and show your support for all your really great weather people. Because, and I just want to throw this out there, I know lots of people look at apps, okay? But if you think that the weather service can go away and you can use your app, that's like saying, I can just go to the grocery store. I don't need farmers. Okay. That's where all the data comes from. And a lot of them work shifts, which is a kind of a, less than ideal working situation a lot of times. So they work rotating shifts. And, disclaimer, I own one of those people. So
I was gonna say, do you bring your son down for this?
This promotion is brought to you by Theo Wellington's son works for the Weather Bureau.
He does. and he loves it. But yeah, he was actually working the evening shift yesterday. But yeah, he comes down when he has a couple days, because sometimes you end up with a span of a couple days where you're not working. So he'll come down, but he's up in Morristown. So if you ever see Morristown, a lot of times it's him tweeting for them.
Well, very cool. Well, thank you, Theo. Also kind of just, pushing us along. If anybody's interested in getting involved with Dark Sky, Tennessee, and, especially around here in the Middle Tennessee area, get in touch with Theo, Bugger, Poker, send her a message on groups, or she's pretty public in our club. So if you can find her. Also in that article from the Night Sky Network, there's a link to this. Let's see if it'll go. theglobeatnight.org. And I'm a pretty big fan of citizen science projects where part of the community can take help build research data, essentially. And so you get more data points all around the world, especially something like this. And what they're basically doing is going, hey, can you see Orion? And you go, oh, well, there's Orion right there. And they basically have a desktop app where you go, all right, how well can you see Orion? Like magnitude 3 would be barely making out our little friend down here. And it asks you how many stars you can see. And so the the more magnitude you get, obviously the more stars you're going to see here. You can tell when you observed where you're at, and then you'll essentially, tell it what kind of sky it was. Was it, slightly cloudy, partly cloudy, no clouds, horrible clouds? And you could submit this data. If you have a sky quality meter, you can plug in like what number it was, and it'll automatically plug this in to where it's at, so it'll sync up to whatever your sky quality meter is. And it's essentially data that is looking at changing the changing sky over time. And so if it's something else to kind of add um, to your night sky interests if you're out and about. There's also a citizen science project that runs through a phone app where all you do is hold your phone up, you put it on a flat surface, and you just take a picture of the sky, and it records brightness levels there. And so you get, all these people around the world just, pointing their camera at the sky and getting, day by day readings of how the sky is changing. So it's a lot of really cool things going on with that. So again, if you're interested in the dark sky stuff, reach out to Theo or one of us on the board. We can, get you some good information. Also on Night Sky Network, sitting alongside that, Night Sky Notes. Again, if you're interested in astrophotography, here's a little article they wrote up: astrophotography with your smartphone. And yes, I've managed to snag Andromeda Galaxy with this smartphone. I chose a nice big target that you can get and so it doesn't take much to take cool pictures with the sky, and this article is kind of playing on that. So again, if you're interested, just point up. All right. Continuing our tour through Night Sky Network, there's a lot of really cool resources in here. As far as outreach goes, a lot of people are kind of scared to go to star parties because they don't know what to talk about. But with this outreach resources and Night Sky Planner, it tells you a lot of really cool things in the sky. If you click on the outreach resources tab, it takes you to a whole bunch of things. But this month they're celebrating the moon. It looks like it's going to be through the month of October. We have a lunar eclipse coming up next month, and so I imagine they're gonna kind of be promoting that. So I always find it interesting, all the promotion of the moon, and if you're interested in deep sky or deep space objects for imaging, you usually kirsten the moon. And this gives us something to look at the moon and be thankful for. So they're celebrating the moon out there. And here's some cool little facts and things like that throughout the year that you can look at and learn about our friend in the sky. In that Night Sky Planner, speaking of the moon, you can find current data on the moon. You can see how bright it is outside. You can see this is tonight, 57% full. You get sunrise, sunsets, things like that, so you can plan your day better. On here, there's also links to clear sky charts, sky maps, and spot the station. And so today was the first time I actually kind of dove into those buttons on the right there. I mean, I knew what clear sky chart was because we have a link to it on our website. But whenever you click on that link, my brain had never really processed that like that data comes from a big map. And so it's pretty cool because it shows all the sites where there's data for. And so if you're able to kind of click in here where Nashville is, it'll pull up the four closest, well, because I clicked on it, it'll pull up the four closest areas where readings are available. And so BSAS is one of them, or Tennessee and Dyer, and there's a couple other around the area. But here you can see, all the white. All right, white's bad, dark is good, and so the darker it is, the better sky it is. So that's a pretty cool little link there. And then continuing on, I clicked on the Sky Maps thing, and I've gotten access to Sky Maps clicking another link off of there, and it wasn't these. And my brain's going, what did I click on? But this is it's a free map. And so if you're interested in a sky map, you essentially take these out. You can see there's directionality. You kind of point it towards north, and then you look up, and you can see that the stars will align. It's essentially a little road map for you to find things in the night sky. Here on the left, you can see potential things that are going on in the sky, so things to look for. So coming up. Let's see, what day is today? The 19th. So we're almost to the last quarter moon. Moon near Antares in a couple days. So wait, that's Friday. Yeah. I don't even know what day today is. But also on the backside, they have some really cool hints and tips of things that you can see with your naked eye and binoculars and telescopes. So again, if you're wanting to do some outreach, you can be like, hey, there's some really cool things you can see with binoculars that you don't just need a telescope to enjoy the night sky. So again, free resources through the Night Sky Network, and you don't have to be a member to get access to these. So it's another really cool thing. And then finally, what I found was great was the Spot the Station. Now I've used the Spot the Station website before, and it's changed a little bit because in the past you essentially had to go through and uh, create an alert. So you'd sign up for a text message or emails, and it expired after a year. And I don't know when the last time was that I actually got a text message about a space station uh, coming across because I just keep on forgetting that I got those text messages and I haven't signed up. And then this showed up today. And so I had no idea that they built an app. And so with this, I clicked on that and found this. And so the app is actually called Spot the Station, put out by NASA, and it's a free app. And one of the things that's great is that it looks like it'll push a notification to your phone, so you don't need to get a text message. It'll just come through on your phone. And so you can set it up to get push notifications. And once it's all set up, you get something like this. And so here's where I was today when I was at work. Here's where the space station was. Here, its path as it's coming through. And so you can see where it's at in relative terms. I clicked to the to the augmented reality view, and obviously the space station wasn't in view inside my office building, and it wasn't even close to where we were at. I think it was over the Philippines earlier, but it was giving me directionality as I was holding my phone up. And so you could point it to the sky and it'll tell you where the space station is going to be at. And so it's a pretty cool resource if you're sitting here waiting for it. Because I remember many times just staring at the sky going, pretty sure it's this direction. And so there's a lot of cool things there. And then finally, up here, it tells you when the next sighting is. And, so the next sighting for Nashville is going to be March 3rd, but it's in the morning. It tells you 11 days, 13 hours, 26 minutes, 29 seconds. So whenever I took this earlier. And when you click on the next sighting or tap on it, it'll pull up this, and you can set up which alerts you want. So time of day, night, or kind of right before night in the twilight, or the not twilight, but the dawn or dusk. You can tell it how high you want. So like I only want things that are greater than 30, so you only get alerts then. I only want things that are going to be up in the sky for longer than 2 minutes, so you don't get just those real quick horizon buzzers. And then it'll pull up these lists, and so you can look through there and be like, well, I'm not going to be up at 5, I'm not going to be up at 4. You can tap those off. There's also a setting where you can turn off, or you can have alerts only from certain times, so you don't get buzzed at 4 in the morning. So I just wanted to throw a big kudos out to NASA for putting this together in an app, because I keep on forgetting to renew my cell phone text messages. So if you're interested in seeing the space station come by, it's fantastic. It's like a Venus scorching across the sky. And if you catch a really good one, it lasts about 6 minutes going right across the top. And then all of a sudden it just fades away as it goes out of the sun. So it's really cool to see. And this just kind of helps with that. All right. Almost finished up, I promise. As far as previous events and outreach, on the 25th of January, we were scheduled to have a private star party. I don't think I saw that anybody was able to go out there. And as I mentioned earlier, on February 1st, we had a public star party planned for Warner Park, but we essentially got clouded out that day. So we didn't get anything in terms of like major outreach over the last month. It's kind of a dry session, or a dry month for us in terms of what we got out and about, but we're making up for that the upcoming month. So this Saturday, There is a private star party on the books at mile marker 435.3. If you do go out, make sure you have a permit because as part of BSAS, we get access to um, the Natchez Trace. We get access to a few sites out there that we're allowed to be out there all night, and so it's one of those perks of those private star parties. Um, if you're going to go out there, make sure hop on Google Groups and see if anybody else is going out there because a lot of times it's fun to do this with other people. Also, so you're not just out there by yourself off of Natchez Trace. But a lot of times when people start seeing others are going, it kind of rallies the troops and be like, okay, I can do that tonight. So definitely check on Google Groups for that. The next public star party is March 1st out at Bell's Bend from 7 to 9. And then Thursday, I put this up here just to kind of mark your calendars on it. March 13th to Friday, March 14th, we'll have a full moon total lunar eclipse. This is from timeanddate.com. This QR code will take you to this website where it gives you all the information on the eclipse and when and where you'll see it here in Nashville. See, it begins at about 11 p.m. and runs until 5 a.m., but you get maximum obscurity or maximum eclipse at about 2 a.m. So if you're wanting to be up the whole night and go for it, then heck yeah, it's 5 hours or 6 hours of seeing. But you just wanted to shut down after 2, yeah, at least you saw the full, I guess, right? So that's a lot of cool things there. And then finally, one other thing I wanted to bring up is that uh, on March 21st, the MTSEF, the Middle Tennessee Science and Engineering Foundation, are hosting their science fair. One of my coworkers at Belmont, Dr. Steve Murphy, he's been part of this for maybe 20 years now. I don't know how long he's been at it, but definitely a while. And he's always looking for people interested in judging. He, he jokes that if you judge, he'll buy you dinner, and so he brings in a little bit of like box lunches and stuff like that for the judges to go through and look. He usually has over 100 entrances for these, and what these are, they're students or young adults from high schools around the area, some junior highs, and a lot of homeschool kids. And so these are them presenting uh, their science projects. BSAS hosts prizes every year for the top 3 astronomy categories, and so it'd be great to if we could get some members out there to kind of look and do some judging on some astronomy stuff. So if you're interested in judging, astronomy or just general science, because there's a lot of really cool things that the kids are doing. Scan this QR code; it'll take you to this website, mtsef.stemwizard.com. And let me know because Steve would be really excited to have you. And if I give him a bug in his ear that, hey, we got a couple from BSAS coming, I'm sure he'll be excited and put you down for anything astronomy, maybe physics related, radio wave related, things like that. Okay. And then finally down here, both of these are after our next meeting. So March 19th is our next meeting. But down here, I just wanted to put it on people's planning radar. March 28th or the 29th. We have a private star party scheduled, but this is also the night of our Messier Marathon. And Ron, who I see it on here, has been gracious to host over the past couple of years. We've kind of snuck in there and put 2 dates in and essentially said that the 29th is the official day and the 28th is the makeup day, and sneaking in that Friday has seemed to work a little bit. I'm going to knock on some wood here. But Ron's always a fantastic host. If you're interested in this, jump on Google Groups. We'll get more information. But Ron, do you want to say anything? I see it just popped up.
Yeah, I'm looking forward to hopefully we'll have some good weather. I just noted over the last several years, we're probably batting less than 50% on having clear enough skies to have them, but they're fun when we can do them.
Yeah. Yeah. Again, my reign as president, it's going to be, compared to NOAA. We've gotten a lot of rain since I've presided over BSAS. So hopefully the skies will go. I think I don't know if it was last year we didn't even get a chance because every day we tried it was rained out. But that's unfortunately happened. But I don't want to post Ron's address to the public world, but if you're interested, Ron usually posts something on Google Groups, and we can get in touch with you that way. But it's a great time, great event. There are outdoor facilities, and so very very grateful for Ron and his family.
So you said outdoor. I think you meant indoor.
That's true as well, but they're outdoors from your house, so my brain processes it as not having to go inside your house. But they are indoor facilities. There's been hot chocolate at these, so can't make any promises, but there is electricity. So and a warm room to sit in while you're doing your
Yeah,
stuff.
but yeah, the odds are that if it's clear, it'll mean that we've probably had a cold front go through, so it'll probably be a little on the chilly side. Nothing like we're going to be experiencing in the next couple of days, but still chilly.
Yeah. Yeah. Well, we'll keep our fingers crossed. And so with the Messier Marathon, we're going after targets that essentially are coming up right as the sun's going down, and will, you essentially stay out there until the sun comes up because you're going after these things that are right on the horizon, which are notoriously the toughest ones to catch. And Ron's got a pretty good horizon out where he lives. So again, thank you, Ron, for hosting again this year, and we'll have more information on this as well in the upcoming meeting. But just want to get this on everybody's radar. And then
Hey, Tom.
one last, yep.
Thomas Chuck Schlim.
Hey, Chuck.
I wanted to also invite anybody out to the March 14th Star Party at Montgomery Bell State Park. I've scheduled that with them. I'm going to be out there from about 5 o'clock to 7 o'clock doing solar observing and having some astronomy exhibits. And then from 7 to say 10 o'clock, we'll be doing just star viewing for whoever shows up.
Awesome. You sent us an email about that, right?
Yes, sir.
Gotcha. Theo, I think I saw you mention something about putting it on the calendar.
Yep, I'm working on it.
Perfect. Because if you weren't, I was gonna. So I think So Chuck's been working really well with Montgomery Bell, and it sounds like they want to kind of make this a little bit more of a regular thing. So if people live out in this direction, I think Chuck said he lives fairly close to there. So
yeah, I'm about 3 or 4 miles away.
Yeah. So if you live on this side of town, feel free to help out with this because it sounds like it's a very welcoming place. So and you can catch people that are out there that don't even know they're going to come for some stars. So just hijack them in the campground.
We've had a lot in the past. We've had like 100 to 150 guests show up, but this year Montgomery Bell's campground is shut down. They're doing refurbishment all year. So
Gotcha.
I'm only going to have whoever guests we get through local advertising.
Gotcha. So
there might not be as many people as we've had in the past.
Yeah. Well, we'll definitely make sure to plug you on our socials, to reach out to our 2.6 thousand followers. So awesome. We'll get some people out your way. All right. And finally, the next member meeting we have, as I mentioned, is March 19th, next month at 7 a.m. or 7 p.m. I've done that too many times today. Theo will be presenting what's up, and we'll have some stuff together for Messier Marathon prep. If we can meet as long as we're not rained out, snowed out, whatever. My lights just went off. That's freaky. As long as we're not rained or snowed out, like I just went dark. Computer lights. Yeah, right. So anyways, as long as we're not rained out, I think that I have a few Messier Marathon books, stuff like that I can bring. So
Not too much. Just so much that was taking
people
part
can
of
look
the
through them
BSAS meeting.
and see what it's like. But all right, I think that's all I've got. Does anybody have any questions or business to attend to before we take off for the evening?
Sounds good. Thank you.
Okay.
All right.
What's going on?
Well, Well, good deal. Well, thank you everybody for coming tonight. Have a safe rest of the week, and hopefully catch you guys at a star party over the next little bit of time. All right. Have a great day, guys.
Thank you.
All right, thank you.
Yeah, good night.
Good night.